Okay, so now we we want to focus on period changes in the sine and cosine waves. Now, period, if you can imagine, obviously in English, it means like a period of time. It's a unit of time, and a period would be like you finish a cycle, right? You finish from first. First period is that first cycle, right? Goes to the beginning, then the end, and then you go to the next period, so on and so forth. And so, what happens here is we want to be able to change how a cycle, our sine wave cycle, or our cosine cycle. And the reason why we would want to do this is pretty much because nature. All right. Let's go ahead and actually look here on Desmos and what it means, what the period means. Now we have here, here's a sine wave, right? And you can see here that we put a little parameter b, and we have a slider for it in Desmos. Now I'm going to move that in just a second, but you can see when b is 1, essentially it's its default position. Now the default position, sine, starts from 0 degrees, and as we move around the unit circle, we go up to, you guys stop arguing. When we go to pi over 2, the height of the unit circle is going to be a height of 1, and then it eventually kind of comes back down to 0 when you get to 180 degrees, or pi. All right, and then at 3 pi over 2, it reaches its lowest value at -1, and then finally, okay, it actually goes to 2 pi, completing the full circle, and then it continues to spin around. All right, now what will happen though with b, what it does is it pretty much, no, you know what, I'll show you. Okay, so now b is going to go, it's going to get larger. Okay, it looks like a spring. All right, and you can go on Desmos yourself and kind of see how what happens is that if you were to look at the distance from the top, from here to here, okay, that distance is actually changing. That is actually what's called the wavelength. Now, wavelength is measured from going from crest to crest, or you can measure it from trough to trough, okay? But you can't measure it from node to node, because node, you're going to have to go to here for a full period, all right? And so that is essentially its wavelength. All right, now what does that mean in science? Well, if we were to look at sound, so here's a website that has the note A here. You can see that we've got sine, we have a b times x. Now this b is on the inside of the function there, so it's tucked right into x. It's going to multiply to them. And this b is a fancy 880 pi. And you can see here that these are all decimals. It's very all irrational. Now when I play this note, that's A. Now your ears picked up a sound wave that has wavelength a wavelength of this long with a period related to this. All right, that's the B value. Now when we shorten that wavelength, we're going to get C sharp. All right, and if we shorten it even further by having this value of B, it's going to have the E note. Okay, so the wavelength determines the actual note of a sound. All right, and if you ever seen the guitar being plucked, middle C, you have essentially a very long wave, and as you noodle around, okay, you are basically moving the node of the actual wave. Now here's what it looks like when we play the whole chord, all 3 notes together. You can see that it actually creates this very complicated wave here, but it really is just the addition of those 3 waves put together. Okay, so this, if we were to graph this function, this is that chord. All right, now I don't know what chord A and C sharp and E is. Yeah, I don't know. It sounds like might be the A chord. Yeah, so that that's one thing about waves, sound. The next thing we can go into is actually light. Light actually is a wave and a particle, but it's a wave. And so here we can see that if it's a light wave, if it has a long wavelength, all right, now this is the same constant. Light moves at the same constant speed no matter what, but if it has a longer wavelength, it's going to be a radio wave. And as it gets shorter, that that wavelength gets shorter and shorter, becomes microwave, then infrared, and then this little band here is all our evolutionary eyes can actually pick up on. Everything else is escaping our brain. This is all non-visible. And then it gets into ultraviolet light. And I do believe that there are some animals that do see ultraviolet light. In particular, butterflies can actually see pollen through ultraviolet lenses that helps them kind of see, where to go. I think some bees also see some lower forms of ultraviolet light. Then it gets into X-rays and gamma rays and so on and so forth. You can see that these get smaller and smaller. Okay, so it's an important thing that we want to be able to manipulate. So going back to here, what I'm going to do is I'm going to graph the sine equals 1x. So I'm just going to graph the normal sine. All right, and we remember that our highest is 1, our lowest is -1. We go from 0 to 2 pi. Now, what I like to do is I like to graph my whole period first. I like to go my beginning, or from your perspective, my beginning, and then my end. All right. Now, sine wave has a 0 at pi, okay, but cosine doesn't. He starts at a different location. Now, at pi over 2 is where he reaches his max, and 3 pi over 2, he reaches his minimum. All right, so here's our sine wave. And we're going to graph on top of this in just a second. Okay, now that's y equals 1x, or y equals sine x. That's our natural curve. Now we're going to graph y equals the sine of 2x. All right, now what does that do? Well, in order to figure out how to manipulate this, what we want to do is we actually need to know if we're doing this in radians or degrees. Now, what's going to happen in your homework is it's going to be split 50-50. Half of it is going to be in radians. The first half is going to be in degrees. Okay, so this is going to require 2 different formulas. Now, your first formula we'll do radians because that's going to be more common for advanced trig, is the period equals 2 pi over b. All right, that's in radians. And if you were in degrees, then the period equals 180 degrees divided by b. Okay? And so what we do is, in order to figure out, now we know the period is 0 to 2 pi for sine. Okay, that's its natural, cycle. Here, if I have a b of 2, I need to, and I know that it's in radians, then I'm going to say the period equals 2 pi over b. Now, b is located right here. It is the 2. So I'm going to put over 2. Now, watch what happens as the 2's cancel out. We find that the period is actually pi. So this means that sine no longer goes from 0 to 2 pi to complete a full cycle. What it does is it cuts that in half. It's actually going to squeeze in and complete a full cycle from 0 to pi. So that's going to change. So what I do is I make sure that I mark my first dot at 0, and then I mark my next dot at the end of that cycle. And then I just kind of section it off and recreate this symmetry. All right. So I go from 0 now to pi for a full cycle. And now I know that in the middle, a sine wave does this. Okay. It actually has a 0 right here in the middle. So I put a 0 here because I need to recreate right here, right in the middle of those two. I need to recreate that curve in half of the space. Okay, so that is y equals sine of 2x. Now, because I have this graph still available, I need to fill the rest of it in. So here, this guy and this guy is now the second cycle. So my node happens here. I go all the way up to 1 and all the way down here at -1. So this cycle will duplicate itself going here. Okay, so you can see that sine equals 2x means this number right here means how many cycles actually happens in a normal 0 to 2 pi or a normal 0 to 180. Okay, so that's what we want to remember. This kind of gives us the cycle. Now, a period is very close to frequency. All right, but we're not going to get into that right now. We'll kind of get into that as we get into applications. But right now, this B value has this effect on a sine wave. All right, so I'm actually going to stop this video here, trying to get it to 10 minutes, and then we're going to get to what happens if there's a fraction, what happens if it's cosine. All right, that'll be our next video.